Here is a pretty jarring reality for 2026. Like, absolutely everyone is using AI, but almost no one is actually running their business on it.
Yeah, that's the real bottleneck we're seeing right now.
Right, because Mackenzie just reported their latest state of the industry numbers, and it shows that while 55% of organizations are actively playing around with generative AI, a mere 18% have actually deployed multi-agent orchestration systems in production environments.
Which is just a tiny fraction, compared to the hype.
Exactly. So if you are a business leader, a CTO, or developer listening to this right now, you really have to ask yourself a provocative question. What do those 18% know that you don't?
It really is the defining gap in the market right now. And I mean, to understand how to cross that chasm, we have to recognize the massive fundamental shift that happened between 2024 and 2026.
The shift from just experimenting to actually operationalizing.
Precisely. 2 years ago, we were stuck in this experimentation phase. The whole debate in the boardroom was simply, should we adopt AI?
Right, just getting the feet wet.
Exactly. But today, the conversation is entirely about building the operational infrastructure to support it at scale. Moving away from isolated chatbots toward autonomous, agentic workflows, it isn't just an interesting tech trend anymore.
It's mandatory.
Yes. For European business leaders especially, it is a strict competitive necessity. You either build the infrastructure to support these agents, or you get left behind by the companies that do.
Well, welcome to the deep dive. Today, we are unpacking an incredibly detailed blueprint from AetherLink.
It's a fascinating report.
It really is. It focuses on Amsterdam's 2026 AI infrastructure. And our mission today is to trace the path from that 18% adoption rate to the actual future of enterprise operations.
Sound like a solid plan.
So to do that, we need to start with the shift you just mentioned, the transition from relying on chatbots to building out microservices.
Right.
Because to understand why 82% of companies are totally stalled, we have to look at how AI architecture itself has been completely decoupled.
Yeah, because for a long time, the dominant mental model of AI was, well, the personal assistant.
Right, like a super smart intern.
Exactly. You open a browser, type a prompt into a large language model, and it leaves you an answer. And, personal assistants are incredible for individual knowledge workers.
Oh, for sure. They're great at summarizing long emails or brainstorming marketing copy.
Right. But enterprise value creation demands something fundamentally different. Enterprises don't need personal assistants. They need enterprise agents.
Okay, let's unpack this. So we're basically taking the traditional microservices architecture, where developers decoupled those massive monolithic software applications into separate manageable containers, and we're applying that exact same logic to LLMs.
Precisely. Because if you rely on one massive monolithic model to make every single decision in a complex workflow,
It becomes a single point of failure.
exactly, it optimizes for conversational utility, not accuracy. An enterprise agent, on the other hand, optimizes for reliability, for auditability, and API integration.
So it has a very specific job.
Yes, it operates within a strictly bounded context. It maintains its memory state across different sessions, and crucially, it actively connects to your internal business systems to actually execute tasks.
I like to think of it like the difference between a solo chef and a highly disciplined restaurant brigade.
Oh, that's a good way to frame it.
Yeah, like a standard chatbot is a single, brilliant chef. They can prep the ingredients, cook the food, take the orders, serve the tables, and it's impressive to watch them do it all.
Very impressive, yeah.
But if you try to scale that up to feed a 500-seat enterprise dining room,
Yeah.
that solo chef just completely collapses under the context window. They just can't do it all at once.
They absolutely burn out, yeah.
Right. So what we are talking about with multi-agent orchestration is building that brigade. You have a front-of-house agent handling the customer interaction. You have a prep cook, which is your data retrieval system, pulling the right files. You have a line cook agent executing the database transactions. And finally, you have a supervisor agent acting as the expediter, making sure the whole workflow happens perfectly.
I love that analogy. And, Etherlink's lead architecture philosophy explicitly validates this. They state that the future isn't single super intelligent agents, it's ecosystem design.
Ecosystem design, right.
Yeah. And what's fascinating here is that by breaking the workflow down into specialized agents, each point of integration has explicit governance. like traditional IT microservices.
So if something goes wrong, you know where to look.
Exactly. If a customer order gets routed incorrectly, the entire system doesn't crash in some mysterious black box. The system remains understandable. You know exactly which cook in the kitchen made the logical error.
You can just correct their specific prompt or their data access,
Exactly.
which explains that 18% adoption number perfectly. Because hiring one genius chef is easy. You just buy a software license. But building out an entire commercial kitchen with a trained brigade, supply chains, and health code compliance, that takes serious infrastructure.
You can't run a commercial restaurant out of a residential apartment.
Wow, yeah.
And the data proves that enterprise leaders are finally waking up to this reality. Gartner's 2025 Infrastructure and Operations report showed that 67% of enterprises now maintain dedicated AI operations centers.
67%. Wait, what was it before?
In 2023, that number was just 31%, so it's up a staggering 2.2 times. Organizations have realized that autonomous agents require a dedicated AI factory to function reliably.
Okay, so what exactly is running inside this AI factory?
Well, rather than duct-taped ad hoc API calls, a mature AI factory standardizes 4 core components. First, you have data infrastructure.
Meaning the data pipelines.
Yeah, your ETL pipelines and feature stores feeding the agents with clean, structured data. Second, you have models serving the API gateways that allow these different agents to communicate with really low latency.
Got it. What's the third?
Third is monitoring and observability. This is constantly looking out for anomalies like data drift. And fourth, orchestration platforms like AetherDV, which serve as the master control room to manage the state and routing of all those multi-agent workflows.
Let's pause on data drift for a second.
Yeah.
Because for a standard software app, data is largely static once it's logged into a database, right?
Generally, yes.
So what does drift mean when we're talking about an autonomous AI factory?
It is a crucial distinction to make. In standard software, a rigid rule is always a rigid rule. But machine learning models interact with a constantly changing world.
Oh, I see.
So data drift happens when the real-world data an AI is processing starts to statistically deviate from the baseline data it was originally trained on.
You can give an example of that?
Sure. So if consumer purchasing behavior shifts suddenly due to, say, a macroeconomic event, but your AI agent is still using historical patterns to forecast inventory, its reasoning just degrades.
Because it's operating on outdated assumptions.
Exactly. So the AI Operations Center constantly monitors those statistical baselines so the engineers know exactly when an agent needs to be recalibrated with fresh context.
Okay, but if you're a CTO listening to this, you might be rolling your eyes right now.
Oh, definitely.
Because one of the major promises of large language models was that they were supposed to make things simpler and leaner. You write a prompt, the computer does the work. Now you're telling me we need operation centers, feature stores, API layers, and heavy orchestration platforms.
It sounds like a lot, I know.
Yeah, it sounds like we're just inventing another massive IT headache.
I wouldn't call it an IT headache. I would actually call it the exact opposite, the foundation of financial survival.
Really? How so?
AI does not remove the need for infrastructure. It demands highly specialized infrastructure exactly because it makes autonomous decisions.
Ah, I get it. To keep it under control.
Right. When a standard software program runs, it follows a deterministic path. But when an AI agent runs, it is reasoning and acting dynamically. You absolutely need the infrastructure to put guardrails around that autonomy.
Okay, that makes sense from a safety perspective.
But to your point about bloat, the infrastructure is actually what makes running these models financially viable at scale. This really comes down to infrastructure efficiency.
So how does the factory actually solve the cost problem? Because honestly, setting all this up sounds incredibly expensive.
Setting it up is an initial capital expenditure, yes, but running raw, unoptimized models for everyday enterprise tasks is ruinous. Without an AI factory, you are experiencing training-era compute waste every single time an agent runs a task.
Wow.
So a mature AI factory uses optimization techniques like model quantization.
Hold on. What is the actual mechanism behind quantization? I hear that term a lot.
Well, mathematically, quantization is the process of reducing the precision of the model's weights.
Meaning the math gets simpler?
Essentially, yes. You are taking 32-bit floating point numbers and compressing them down to 8-bit integers. The AI conducts the exact same logical reasoning, but it uses drastically less computational memory and power to hold the math.
Ah, so it's like compressing a massive raw photograph into a JPEG so it loads instantly on a web page. To the human eye, the image is identical, but the file size is way smaller.
Exactly. That's a perfect way to look at it. You get the same output, but at a fraction of the hardware cost. Then you pair that with something called inference caching.
Which is what?
So if your customer service agent gets asked, what is your return policy, 1,000 times a day, inference caching ensures the AI doesn't calculate the language generation from scratch 1,000 times.
Oh, that would be a huge waste of compute.
Massive. The infrastructure recognizes the semantic intent of the question and just serves a cast answer. Gartner notes that these infrastructure optimizations reduce operational computing costs by 40 to 60%.
A 60% cost reduction changes the entire calculus of AI adoption. So if setting up this massive pipeline costs capital but saves compute, where is it actually paying off? Like, if an AI factory isn't just generating faster marketing emails, what heavy lifting is it doing in the real world?
You see the most profound return on investment in the most demanding environments. Highly regulated, high-stakes industries.
Makes sense.
That is where the combination of speed, accuracy, and auditability is most valuable. Let's look at a major European hospital network highlighted in the AetherLink blueprint.
Okay, what do they do?
They completely overhauled their radiology workflow. And they didn't just give their doctors a generic medical chatbot. They built a specialized 4-agent microservice architecture.
A 4-agent brigade.
Exactly. First, you have a vision agent that exclusively analyzes the medical imaging to detect anomalies.
So it's just looking at the scans.
Right, and it outputs a documented statistical confidence level. Then second, you have a knowledge agent that queries the hospital's secure vector database to pull that specific patient's history and any medical contraindications.
Okay, and the third?
Third is a reasoning agent. This one synthesizes the image analysis with the patient history against current clinical guidelines.
Oh.
And finally, a workflow agent that packages all of this structured intelligence and routes it to the exact right human specialist.
Here is where it gets really interesting to me. The AI never actually makes the final diagnostic determination.
No, never.
It is just doing all the grueling data correlation to tee up the human specialist perfectly. It's basically preparing the ultimate briefing packet, which in this case resulted in a 34% reduction in diagnostic turnaround time.
And critically, it maintains clinician oversight at every single step, which is absolutely vital.
Right.
We are seeing that exact same multi-agent structure deployed in the financial sector, too. The European Banking Authority's 2025 report showed that 41% of EU banks are now using AI agents for transaction monitoring.
41%, that's huge.
And 38% are using them for risk assessment. Think about the sheer volume of transactions a major European bank processes in a single minute. Human teams physically cannot monitor that for fraud or compliance violations in real time.
Right, but a multi-agent system can.
Exactly.
But there is a reason we keep talking about audit trails and traceability. If a bank denies a transaction using an AI or flags a customer for risk, they can't just tell the European Union, well, the computer said no.
Definitely not.
That legally mandated transparency is driving this entire architecture. A black box just doesn't survive a regulatory audit.
Which is why the multi-agent microservices approach is mandatory here. In finance, you have a data aggregation agent pulling the regulatory files, a risk agent applying machine learning models, a decision support agent making the recommendation.
And someone watching them all.
Yes, and this is the most important piece. You have an audit agent whose sole job is to maintain a complete cryptographic log of the system's reasoning for regulatory examination.
Oh, wow.
Yeah, every single autonomous decision must be explainable and reversible.
Which brings us to the core reality of deploying AI in Europe right now. Because you cannot talk about healthcare or finance without talking about the EU AI Act.
Very true.
Traditionally, tech companies view regulation as a massive stop sign, right? Just a nightmare of red tape that stifles innovation. But what is fascinating in this blueprint is how leading firms are completely flipping that narrative.
They really are. Under the EU AI Act, systems deployed in sectors like healthcare, hiring, or finance are categorized as high risk. And this isn't a suggestion, it is the law.
Right.
High-risk systems require pre-deployment conformity assessments, mandatory human oversight mechanisms, and the maintenance of complete audit trails for a minimum of 30 months post-deployment.
30 months?
Yeah, that is 2.5 years of retaining the exact step-by-step logic of why an AI made a specific choice.
Retaining that much logic sounds like a massive burden on the engineering team.
Well, if we connect this to the bigger picture, I actually look at it the exact opposite way. Etherlink's lead architecture philosophy treats compliance as an architectural advantage.
Really? How so?
By building governance natively into the system from day one, you inherently build a better, more reliable AI.
Okay, I'm listening.
If you build your RH systems, your retrieval augmented generation, to be compliant with the EU AI Act, you have to include strict data source attribution and versioning. You have to know exactly which document the AI read to generate its answer.
Right, because if the regulators come knocking, you need to prove the AI didn't just invent a clinical guideline or a risk metric out of thin air.
Exactly. And by forcing that level of technical traceability for the regulators, you simultaneously eliminate the problem of AI hallucinations for the business.
Oh, that's brilliant.
Yeah, the AI cannot make things up if its architecture physically requires it to cite an authorized version-controlled data source. Furthermore, compliance systems rely heavily on MCP servers.
Hold on, MCP servers. What is that protocol actually doing under the hood to enforce this?
MCP stands for Model Context Protocol. In an enterprise context, you can think of an MCP server as a highly secure, standardized API gateway between the AI agent and your company's actual database.
So it's a gatekeeper.
Exactly. Instead of the AI having raw, chaotic query access to your files, the MCP provides a lockdown interface. It technically enforces role-based access control.
Can you give me an example of how that works in practice?
Sure. So if the AI agent is processing a request for a marketing manager, the MCP server ensures the agent can only retrieve documents that the marketing manager personally has the credentials to see.
So it basically acts as a bouncer for the database, sandboxing the data so one agent can't, like, leak sensitive payroll information to a customer service agent.
Yes. And fundamentally, it prevents prompt injection attacks.
Oh, really?
Yeah, if a malicious user tries to trick the AI into deleting a database table or dumping sensitive data, it just fails. The MCP server validates all the inputs and strictly limits the tools the AI can call.
That's incredible.
The security architecture that satisfies the European regulators is the exact same architecture that protects your company's proprietary data from a cyber attack.
So what does this all mean for the broader technology landscape? I mean, it explains why Amsterdam has emerged as the epicenter for agentic AI infrastructure.
It definitely isn't by accident.
Right, it's a perfect storm of four factors. First, you have regulatory clarity. Because so many firms have their EU headquarters there, they have direct access to AI Act implementation guidance. They aren't guessing what the regulators want.
Exactly.
Second, you have talent density drawing in the specific engineers who actually know how to build MCP servers and multi-agent orchestration platforms. Third, massive infrastructure investment in compliance-ready data centers.
Which is huge.
And fourth, highly sophisticated enterprise clients. Dutch financial, healthcare, and logistics companies are eager to deploy these high-stakes use cases. It is an ecosystem that treats the AI Act as a blueprint rather than a barrier.
And that ecosystem approach is exactly why partnering with specialized consultancies early in the design phase is so critical. Retrofitting a generic chatbot to meet a 30-month audit requirement is nearly impossible.
You just can't bolt it on after the fact.
You really can't. Building a compliant multi-agent factory from the ground up using proven microservices principles is how you actually reach deployment and cross that 18% threshold we talked about.
As you look at your own organization's roadmap for the rest of 2026, my #1 takeaway from this blueprint is simple. Design your infrastructure first, implement the agents second.
100%.
The era of the standalone generic chatbot is completely over. If you want measurable ROI, you need specialized domain agents like that 4-part radiology brigade we discussed earlier. And you cannot run that brigade without an AI factory to support them. Stop experimenting with isolated tools and start standardizing your data pipelines and orchestration layers.
And my #1 takeaway is really a shift in mindset. Governance is not a roadblock. It is a blueprint for scalability.
That's a great way to put it.
The organizations that are winning right now are the ones building human-in-the-loop oversight and clear audit trails from day one. By embracing the mandates of the EU AI Act, forcing clear boundaries, state management, and traceability, you inherently build a system that is faster and more reliable than those trying to hack compliance onto a fragile system later. Governance forces clarity, and clarity is exactly what autonomous systems require to function safely.
It really is a complete paradigm shift from how we thought about AI even just a year ago.
It is. And as we transition fully into this orchestration era, I want to leave you with a thought to mull over regarding those mandatory 30-month audit trails.
Okay.
In these multi-agent systems, we have supervisor agents constantly, tirelessly reviewing the performance and reasoning of subordinate agents, documenting every single logical step in cryptographic detail.
Right.
At what point does the AI's internal mathematical auditing become fundamentally more rigorous and reliable than the human managers tasked with overseeing it? How will our traditional corporate hierarchies adapt when the most transparent, accountable, and flawlessly documented manager in the room isn't a person at all, but the orchestration layer itself?
Man, that is a wild thought to end on. The restaurant brigade, where the absolute best executive chef is the software. We have gone from the messy, muddy waters of figuring out what AI is to realizing we now have to build the exact precision infrastructure to contain it. For more AI insights, visit etherlink.ai.